Good day, everyone. Welcome to FIT3143. In today's video, we will be providing you all with a quick overview of the C programming language, which we will use in this unit during the course of the semester. Okay, so maybe I can start sharing my screen. Okay, so initially, I've shared with you all a website which provides you all a good tutorial on the C programming language. And this website actually contains some background about the C language and some motivations about to learn the C language and some facts about the C language itself. All right, so in history, C language was created in 1972 by Dennis Ritchie at the Bell Labs, as part of the develop the Unix operating system. Right, and Dennis passed away peacefully in 2011. Okay, so but since its creation in 1972, C has evolved, and C remains today as one of the world's most popular programming language, especially when developing real-time applications. And C++ is derived from C, or you can say C++ is an extension to the C programming language to include classes. So C++ was initially created in 1979, started in 1979, and then it went into the 1980s. The creator of C++ was John Strostrup. My pronunciation might be a bit off there. And as I mentioned earlier on, so C++ is an extension to C. So in this unit, if you are familiar with C++, you can continue to use C++ for this unit because C++ provides backward compatibility to the C programming language. Nevertheless, the rest of this video will be based on the C programming language, and your unit lab activities are also based on the C programming language. All right, so moving along, the thing that I would like to explain to you all before I go further, I understand that all of y'all would have, or all, at least a majority of y'all would have some training in Java. And just to do a quick comparison between C or C++ and Java, as I mentioned, C++ is C with classes, it's an extension to C. So when I compare C++ with Java, I'm also comparing C with Java to some extent. All right, the important thing is this, okay? Java is an interpreted language, which means that it is translated to binary at the time of execution. That's why in Java you have a runtime engine. This allows it to run on any operating system, regardless of where it was written. Okay, C++ is a compiled language, which means that your program is compiled on a specific operating system and only runs on that particular operating system. So that's why if you're writing a C or C++ application, you need to use a compiler specific to the operating system. So in this case, we are using GCC, which for Linux environment. So let's say if you're writing a C language, if you're writing a C program, if you're writing an application using the C programming language on the Windows platform, you could use Windows supported compilers for C, for example, like the Microsoft compiler and also other compilers also. All right, so Java is a memory safe language, which means that if you attempt to assign values outside a given array parameters, the programmer receives an error. C++ is much more flexible, but it comes at a price, in the sense that if you're not careful in memory management in C, your program might suffer a segmentation fault. All right, or in other words, the program will crash. In terms of performance, Java is slower because of the interpretation during runtime. C++ is compiled to binary, so it runs immediately. So that's why, and as I mentioned earlier on, C and C++ are more popular, or applications written using the C or C++ language are more popular for real-time systems. So if, like, say, you're developing an autonomous vehicle system, or you're developing avionics, software applications for avionics and so forth, in those kind of environments, using the C or C++ language provides a much more, enables you to create applications which runs much more faster. All right. The most important thing that we'll cover today is pointers. Pointers are C++ construct which allows you to manage values directly in memory spaces. Java does not support pointers, so you're only able to pass value using value references. So that is the main difference I wanted to talk to you about. You can find this online. Okay, so I actually sourced this information online. So generally it's a general information, general knowledge. Okay, so let's go to our virtual machine. Now, in the virtual machine, I've created the following files, and these files will be made available to you in Moodle alongside this video, or you can also get the files on the video description later on, so don't worry about that. So I'm going to explain C by providing some examples. All right, so I've created a few C code files here, a vector, and then several versions of a matrix file. So generally what all of these files are doing is that they're creating a vector, a matrix, writing the matrix to a file and reading the matrix from a file. So as I explained to you all the code, I'll also show you how to compile the code. I won't be using a makefile, I'll be using GCC. I'll just be using GCC. Eventually later on we can use makefiles to actually compile multiple codes and so forth. So that actually makes the compilation process a bit more easier. But that's something that we will cover in the labs, I think in the following weeks ahead. Okay. But for now, I think the emphasis for this video is just to give you an overview of the some of the programming constructs in C. So before I go to the code files here, just quickly I'd like to show you. So I've got this article from Medium by Laura. I think she did a very good article on the C compiling step process using GCC step by step. So generally speaking, maybe I can zoom in a bit to this page over here. So if you have a C code file, a source code with, written using a C language, when you compile using GCC, the first step is the preprocessor step, followed by the compiler. The compiler will generate an assembly code, okay, and then the assembler will create the object file, the .o file, and then during the linking stage, the linker will link the libraries to the functions which were called in the object file to create your final application or executable file. Now, I would like to reiterate that in this unit, we'll be using C language to create applications which will run at the terminal. We can also call it as console or terminal-based applications. We are not going to use C to create graphical user interface. That will require additional packages, and that's currently not within the scope of this unit. But nevertheless, let's say during the assignment, if you feel like you would like to do some additional work to create a graphical user interface, to visualize some of the outcomes of your assignment, we definitely welcome you to actually explore and implement that. Okay, now, so I'll go through quickly this site. I mean, the link, I'll provide the link to this page in the video description and also in the Moodle page for week 2 of your learning activities. So now, generally, there are a few steps in the C programming. As I mentioned, compiling has 4 steps: the pre-processing, compiling, assembling, and linking. All right. So so given a source code here. So the preprocessor, okay, includes the code of all the header files. Okay, what is the header file? I will explain to you later on the header file. Okay, and then you will replace all the macros with their values. Okay, this is the first step of what the preprocessor does. And then the compiler will then generate an intermediate representation code. All right, so the compiler is the main element that actually compiles the code and generates an assembler for it. So if at any point of time, if there's an error in your code, it will throw a compilation error. And then the assembler takes the IR code and transforms it into an object code, which is in a machine language, okay, a binary file. And then finally, a linker creates the final application where it links all source code files together, all object files into an application, or it links the function called with their definition over here. So this is generally the entire process of the C programming language. So in that sense, you see there's no interpreter required in C language. That's why it makes the compile application using C. When it runs fast. So when you launch the application, the operating system, the operating system's loader loads the application into memory and then executes the instruction in memory. So that's how the a compile C application actually works. Now, so once we have gone through that, now let's go into the code. So now, if I open the first file, so I'm using the virtual machine environment here just as a baseline. If you have your own Linux environment set up, by all means, please proceed to use that. Okay, so now I'm going to open this. I'm using Pluma. It's pre-installed with the virtual environment here. Okay, so again, bear in mind, if this virtual machine was created by Paul Miller, our head tutor, and please make sure that you are, by this point, you already have the virtual machine set up, or if you are using a Linux as a native operating system, you also have got that system set up in your computer at this point already. All right, so now what we have here is a C file. So this is the header file. All right, so I'm using C99 and above, the C version 99 for GCC. So it allows this type of commenting. Otherwise, I will need to use something known as the /* and then * / commenting. This is one of the earlier versions of the C compiler uses this commenting format. You can still use this commenting format, or you can use the / to actually comment a code. Okay, this / actually comments a code. All right. Okay. Anyway, so what we have here, so you see, so in C, you will need to include some common header files. I mean, standard header files. All right. So in any C program you write, you will need to include, this is the standard input/output header file, especially if you are doing input/output processing. All right. So this is important. The stdio.h, stdlib.h. Okay, this is important, especially when I'm doing some file processing later on. Although I'm not using the functions inside some of the header files, I'm just putting it here for good measure. And then memory.h if you're doing if you're doing any memory manipulation or processing task. And then time.h later on, because I'm going to use a time function here as part of when generating a random function. So I'm sorry, when generating a series of random values using a random function. So these are the header files that you need to include in C. So normally if you include a header file, you use the left angular bracket and the right angular bracket, and then you put the header files. So normally the angular brackets are used when you include header files which are already predefined by the C compiler itself or the C standard itself, like stdio, stdd, memory, and time.h. If you were to create a custom header file, or if you are using a third-party library, like later on when we use POSIX threads, then typically you will include the header file. You will include the header file in double quotes .h. Okay, if you're to create your own header file, or you're using third-party libraries. All right, so this is something I'll just like to just show it to you all first. We won't be using it now. Maybe you might use it in an assignment. That depends on how you actually write your assignment code later on also. All right, okay, so what I have after that here is a symbolic constants. Okay, this is a symbolic constant, so I'm using a hash define that defines a symbolic constant, and then this is the value that associate with this constant. So after that, I can use this variable throughout the entire program. So what is the benefit of using such symbolic constants is that if I need to change the value, I can just change the value here without having to change the value throughout the code itself. So it kind of eases the writing experience of your code. And then the same thing here also. So I've created two symbolic constants over here. Now, the most important thing in any C function is the main function. So the main function is your entry function. So any C program, any terminal-based or console-based C application, okay, requires a main function. Now, you may notice that some C functions actually have an additional argument like argument counter. Okay, and then after that, another one is char pointer to pointer, p argument, pp argument, something like this. Or char pointer, p argument, and then an array ID. So it's a pointer to pointer. So this is normally used when you are passing in command line arguments when you are invoking a C application. I won't go into this today. Maybe I'll cover this later on in the labs or during other videos in the future. Okay, but for now we will just have a main function with an empty arguments. All right. So this is a function. So we have the function name. As I mentioned just now, you can pass in arguments inside here. So typically in this case, we'll leave our main function to be empty. And this is the return type of the main function. So we use an integer and we'll return 0 by default. Now, so inside the main function, then you'll specify your variables and your instructions or the algorithms that will carry out the task. So in C, we are using We can use variable. We can define variables as integers. Integers are round-based variables. They carry round values only. We can use char. Char I used to define variables as characters. Okay, we can use unsigned integers, which means integers in this case are round numbers, but the smallest value to start is 0. If I use integers, they can store round values, but they can have negative and positive values. So all of these you can actually find more information in the links to the tutorials that I shared to you all at the beginning of the video, or in Moodle itself also. So what I'm doing here is actually I've declared a few variables here. All right. I put a matrix name inside here, but we are not actually using this particular variable, so we can delete this for now. All right. Then I've declared a random variable for a random number. I initialize it as 0, and then this is an array. Okay, this is an array. So arrays are something if you're familiar with. You learned it before in Python and also in Java also. So similar context here. We have an array, and this array is of type integer. So I can specify different types of array, float, char, and so forth. So when you specify an array, is like a container. It's a container that stores an X number of elements. The X is defined by the size of the number of elements inside here, and each element has the same type. So in this case, I'm specifying an array of type integer of array size. So which means the array size is 100 here, which means that this array will store 100 elements. It will store 100 elements of type integer. So which means in total, if I were to ask you, what is the size of this array in bytes? What is the size of this array in bytes? Okay, so each element is an integer. So we are using a 32-bit compiler over here. So 32-bit compiler means that integers carry a 4-byte value, So which means that if you take 4-byte value, 32 bits to the power of 32 is 4 billion estimate. So which means that integer, the smallest value you can store is minus 2.1 billion, and the largest value you can store is positive 2.1 billion. Okay, and you can store 100 of these integers. So coming back to my earlier question, if I were to ask you what's the size of the array in bytes, which means 100 elements, each element is an integer, one integer is 4 bytes, so 100 into 4, it is 400 bytes. 400 bytes. This is the size of the array, all right? And this array is a stack array. So technically meaning that to some extent, okay, the size of the array is actually known at compile time. All right, so that's a stack array. So now, the next line is so now how do I print a message on screen in C programming? You will use a built-in function called printf. Actually, printf is defined inside the stdio.h. So the stdio.h contains the function prototype for printf. So when I specify the function prototype inside the when I include the stdio.h, the preprocessor, as I mentioned earlier on, will load all the function prototypes and from this header file. So which is why when I call this function, the compiler will then see the usage of this function in relation to how the function was declared in the header file. And if the usage is correct, the compiler will allow, will not throw an error. It is the linker that will then link the call of this function to the function body inside the libraries, inside the standard libraries in C. All right. So in this case, I just want to call print. So I use a printf. The printf stands for print function, and I specify a text here in double quotes. I use /n to specify new line. So you will after printing this message, you will jump two new lines. Okay, and then after that, what happens here is this. Okay, I'm going to populate the array. Okay, with a random value. So I'm calling the rand function. So the rand function is also a built-in function. I think it's inside the stdlib, if I'm not mistaken, if my memory serves me correct. Okay, I call the rand function. So the rand function actually generates a kind of a random value. So if you search up the rand function, okay, if you search up C rand function, okay, so the rand function. So the rand function returns a pseudo-random number in the range of 0 to rand max. In rand max, in this case, is 32,767 values. Okay, so that's why I'm calling this function. So you will return me this value, and then I will then scale this value to this element. So which means that I want to make sure that the random value will not exceed 1,000. Okay, or at least, yeah, will not exceed 1,000. So that is the function I'm calling over here, and then will not exceed 1,001, and the smallest value will be larger than 0. So I have +1 over here. All right, and now I'll store this value into the array at location I, where I iterate from I0 to I less than array size and I++. So remember, in C, we use the semicolons. So semicolons are very important in C, okay, to actually differentiate between different syntaxes. So that's very important in C, all right? And then when I want to print the array, I can actually print the array in the same for loop, but just for the purpose of simplicity, I'm just separating out them together, separating out both for loops. I run another for loop again, where this time I call a print. So now you see in the earlier print message, I just print a text, but now I want to print the content of the array, so I can use a conversion specifier. So I can use a conversion specifier. In this case, like I'm using the conversion specifier %d. %d means it prints an integer. %f, it prints a float value. %c, it prints a char value. Since this array is an integer value array, so I'm using %d. I'm printing out the array. I'm printing out the array value at every iteration over here at element I. Okay, so that is the general layout of the code. Very simple code over here. Okay, so let me save. So I use Control S. I can use the save button over here also. Oops, sorry, that's not save button. My bad. That's okay. So the save is already saved already. All right. Okay. So now let me open a terminal. So terminal is pointing to my directory over here, FIT3143 in my home folder. All right. So if I do ls, I can see all the files. So now I'm going to use the GCC command. Okay. So GCC command is the new GNU C compiler. All right. So I'm going to use the GCC command. There you can specify several commands when calling the GCC compiler. I'm only going to specify one specific command, which is -warning all. So I want to show all warnings. And then I specify the code which I want to compile. So in this case, I'm compiling the vector.c, the first code. And then I specify output file, -o, we specify what is the name of the application file which will be compiled. So as you can see in the folder here so far, I only have the code files over here. Okay, if I hit enter, all right, I'm getting some warnings over here. It says what here? Unused variable rand number. Unused variable rand number. So I get this value over here, unused variable. So this means I declare this variable but not using it. Okay, fine. If I have to comment out this variable, what happens next? Okay, so I get some warnings over here. All right, so let me go back to the code again. Sorry, maybe I should clear it up, make it easier to see. All right, so I get some other warnings like unused variables, J, column, and row. So these are all unused variables. I mean, yeah, it's fine. If I just declared that because initially I was using them, but then I'm not using them, so I can comment them out. All right, so it's just some minor warnings. So warnings doesn't mean that the program won't compile. As you can see over here, the application is actually compiled already. The output file is actually an application. All right, but if you want to get clear warnings, you want to get no warnings at all, then you might want to fix it. But then you can see here, there's a mistake because I've inadvertently commented out the I variable. So let's say in this case, I only want to keep the I variable over here. So you can see if there's an error, then the compiled application will not be compiled. All right, so just be careful about that. Okay, so you can see over now, I run again, bingo. So now we have no errors already. So now, if I were to run the application, I will do a // I will execute the application. So it generated a sequence of random numbers. Okay, if I run the application again, I'll get the same sequence again. So why isn't there any randomness? Okay, that's because of the nature of the rand function. Okay, so this function actually uses the same sequence. All right, it generates the same sequence. That's why we have to use the csrand function. All right. Okay, so this srand seeds the random number generator by using the function rand. Okay, if you don't use a seed, the rand function will generate a default seed with value 1, which means that's why you'll get the same sequence over and over again. So we will need to set a seed which will be used by the pseudo random generator. So in this case, normally it's good if you want to create a truly randomized sequence of number, the seed must represent a value that keeps changing. That's why one value that changes linearly is time. That's why in my code over here, in the sample code over here, I actually included a time.h, and then initially I commented out this code. Now I'm going to comment it out, uncomment it. I'm going to call the seed random function, and then the seed random function takes in any value. It takes in any value, but in this case, I'm going to put in the time function, specify as null. So when I call a time function is a built-in function. I use the time header file, and I pass in a null argument here. It returns me a 32-bit value of the current time of the operating system, and then I'm casting this value as a unsigned integer. Okay, so based on that, now when I call the rand function will be based on the seed value. So you only call the seed value once. You don't have to call the seed value inside the for loop. Before the for loop, call it once only. And based on this time, based on this seed value, it will generate a sequence of random numbers. So now, if I have to save the code, and then if I were to compile again, remember every time you modify the code, you have to compile the code. Okay, every time you modify the code, you have to compile the code. And then now if I have to run it, so I get one sequence of numbers. I run again, I get another sequence of numbers. Run again, I get another sequence of numbers over here. So that is a general idea of how you can generate a vector. So in this case, I'm generating a vector. So a vector is a one-dimensional, technically a one-dimensional array over here. Okay. Now, so once we have understood, so this is just a general layout of C. I mean, a very basic one. Now, I'm not, as I mentioned, I'm not going into very in-depth into the C language itself, because I hope you will do some self-learning along the way also. Given that you already have background in Python and in Java, so I believe that learning this language shouldn't be difficult. All right, I think the slightly tricky part is the pointers, which I'll come to that shortly. So this is the first example. Now, let's say I would like to create a matrix. So a matrix is a it's a two-dimensional array. So let's open my first version of matrix. Okay, version V1. So it's the same example as before. I'm just extending it into, as you can see, the difference between this example, the previous example. Of course, you might get the same warnings again for some of the unused variables. Maybe I should just comment out this code over here because we're not using the rows and columns. Okay, and also the name. All right, the matrix name is still fixed over here. So as you can see over here in line number 24, the difference between the previous example is now this is a two-dimensional array. So you can create multi-dimensional arrays in C, all right? But just bear in mind, the more dimensions, so how you specify dimension is you specify an additional square bracket, all right? So, but be careful, the more dimensions you create, the more memory it actually uses up. I mean, yeah, to that extent, but it depends on how you interpret the memory also. So, nevertheless, I'll just focus first on a two-dimensional array. All right. So in the two-dimensional array over here, all right, so you can see that we specify the first dimension is the row, specify in the curly braces. Second dimension is column. I'm using row and column, which are defined as symbolic constants again, 10 and 5. All right. So again, the same thing, everything else is the same over here. Now you can see I'm using a nested loop. I'm using a nested loop, whereby in the nested loop, okay, I will, for every row value, I will iterate the columns, and then at each row and column value, I will store a random value over here. And then the same thing, I will print out the values over here. All right, that's generally, it's very much similar to the previous example. And if I were to clear the program now, this time I'm going to compile matrix underscore v1.c. Okay, I'm getting another, yeah, probably just comment on this line, right? Okay, then if I were to run the program now, I will have my random number generator for a 2D matrix. I mean, for a matrix, you can see there is a different sequence of numbers. Okay, so in actuality, although you are representing your array as a two-dimensional array, the compiler sees it as a one-dimensional. So actually, when the compiler compiles the code, and the compiler will actually generate the assemblies, generate the assembly code, which when run at runtime will search for a contiguous or continuous elements in memory of row times column. In this case, 10 times 5, 50. So you will look for 50 elements in memory. Since it's an integer, so 50 times 4, 200 bytes. So you look for 200 contiguous, 200 bytes in memory which are empty, and then it will reserve that entire section of the memory for your array. So maybe I can draw it for you all here. I mean, later on I can give you some guidelines also. Maybe over here. So generally speaking, all right. So your memory is nothing much. Your memory in your system memory, yeah, your system memory is nothing much than an oops, sorry, maybe I should just, okay, it's nothing much than an array of cells. Okay, an array of cells. I'm just representing them as a 2D array also. All right, it's nothing much than an array of cells. All right, it's an array of cells. Each cell, okay, each cell contains an address. Okay, each cell contains an address. That's why if, let's say, if you have a memory of 8 gigabytes of memory, okay, if you have 8 gigabytes of memory, which means that you have 8 billion bytes available in memory. Each byte has an address. Okay, that's why you will need to use a 64-bit addressing mode. You will need to use a 64-bit addressing mode. Okay, here. Now, what is a 64-bit addressing mode? What is a 32-bit addressing mode? The reason is because each address, if you have 8 billion bytes, you will need 8 billion addresses. So assuming let's keep it very simple. Let's say the first address starts at, let's say, 01. And if you were to increase the address value all the way until the 8 billion bytes, so the last address will be 7,999,999,999 bytes. All right, that's the 7.99999 billion. That's the last address. So to have a variable that can store that address, that variable needs to be a 64-bit variable. A 32-bit variable, as I mentioned earlier on, can only store the largest value is 2 to the power of 32, 4 billion. So if you have a memory, if you're using a 32-bit operating system or a 32-bit compiler, especially a 32-bit operating system, your memory address space is only limited to 4 gigabytes. That's why today, in today's operating system, especially for today's general purpose operating system, they're all running at 64-bit addressing 64-bit addressing mode. So which means that they can actually, the operating system is able to access more than 4 gigabytes of memory in the entire memory space. So you can go to 8 gigabytes, 16 gigabytes, 32 gigabytes, and so forth, up all the way to the power of 64. It's a very large number. All right. So coming back to our example, so just now my row was 10, my column is 50. My row is 10, my column is 50. I created a 2D array of 10 by, sorry, my column is 5, my apologies, 10 by 5. So you multiply them is 50. So what the compiler does is it will generate the assembler code such that when it runs at runtime, okay, it will look for a contiguous set of cells. In this case, 50 times 4, 200 bytes because it's the integer. It will look for a contiguous row. It can be multiple rows over here. I'm just putting it here for illustrative purposes. So in this case, we're looking at, say, 200 bytes. And then it will reserve this entire region in memory for that particular array. It will reserve the entire region in memory for that particular array. So that's what is happening over here. Okay, so let me go back to the code again. Okay, so generally, although you're using a 2D array, but the compiler actually interprets it as a 1D array. It's just that in terms of writing the code, it looks much more easy in this context. All right. Okay. So this is a simple matrix application. Now, let's go into something much more in depth. Okay. Now, what happens? Now, as you can see, my earlier example, this one I'm just creating a fixed size. So let's say I come to you. I said, okay, I want you to create a matrix of 10 by 5. Okay, so you have this matrix file, you run the code, you generate a matrix and say, here you go. Now I said, now I want the matrix to be, let's say 100 by 50, something like that. Okay. So what happens is every time I give you a new requirements for the matrix size, you need to recompile the file again. So that it's not very intuitive. Okay. You want your program to be able to run, compile once, and then you're able to specify at one time what is the size that you require, and then the program will generate the matrix for you. So that is the more desirable outcome. Okay, so in that context, so let me go back to the folder again. All right, so let's look at the next example over here, matrix version 3. All right, so in matrix version 3, now, version 2, my bad. Okay, in matrix version 2, okay, so now I'm now using a variable size array. So I'm declaring integer row column. So now this time I prompt the user, specify the row value. So when I want to get a value from the user, so I'm introducing it to a new function called scanf. Now guys and girls, if you're familiar with C++, okay, if you have learned C++ during your course of your study, you can use C++. So which means instead of using stdio.h, you'll be using what? You'll be including iostream. And then instead of using printf scanf, you'll be using what? C.C. So by all means, you can actually use that if you want to. All right. It's just that I'm using C as the baseline here. All right. So here I'm going to call scanf. So scanf reads, is a scan function. It reads from the terminal what the user enters. So in this case, I'm expecting an integer value. So I've used %d. I don't specify any /n or any escape characters inside here. Just the conversion specifier, %d. And scanf is like your postman. It takes the value and it needs to deliver the value to a variable. So it needs to know the address. It needs to know the address of the variable. So that's why to get the address of the variable, we will use the ampersand symbol. The ampersand symbol. So I specify the ampersand of the variable. Same thing for column. And then I'll specify the ampersand of the column. All right. So for example here, I can then print out, let's say, all right, just for the purpose of demonstration. Okay, row value %d, column value %d /n. And then, so normally you use /n/t and so forth in the printf. Don't use /n/t in the scanf. Scanf just stick to the conversion specifier. Do not put any text or any messages in scanf. Just the conversion specifier, whether it's %d, whether it's %f for float value if you're reading a float value, or %c if you're reading a character. All right. So now when I call a print function, I specify row and column. Now you'll be wondering, why is it scanf requires the address, printf doesn't require the address? Now that is the nature of how scanf works. Scanf, it needs to identify where to write the value into the variable. That's why it needs the address of the variable. Whereas printf just reads the value of the variable, by which the compiler actually knows the location of the variable when the variable is actually declared. So that's how the printf and scanf functions actually work. So you do not need to specify the ampersand when using print. Another reason for that also is because of the way it works. Now, if I were to specify address of row, I'm not going to go to the address of row and read the value from there. Instead, the print function will actually print the address value of this variable. So that's one reason why the print function is designed to be able to read directly from the value of the variable without having to specify the address. Because otherwise, if you were to specify the address of the variable, you won't be reading the value of the variable, but instead you'll be reading the address of the variable, which is in memory. All right, so that's how the print function actually works. Okay, so now so I can print out the values over here, and then from here you can see I'm using something called variable array length, VAL, or variable array size, VAS. Okay, so this one it's still technically in a way I'm using a stack array, but this time the size of the array changes in runtime because the variables here are dynamic variables. They're not constant variables. Some compilers, bear in mind, the GCC compiler allows this, but some compilers may not allow this. If you're using a Microsoft compiler, there's a high chance you will get an error over here. That's why it's better to use heap memory, which I'll go to next also. All right. So in that context, okay, I declare the array and then the row and column over here, and then the rest of them is exactly the same. So the benefit of using this method is I can now change the value of the row and column every time I run the program. So let me save this program. Okay, let me save the code. Let me go to the file. So this is version 2. Okay, version 2. Okay, compile, no errors. Now I go to the output file. Okay, so now you see it asks for the row value. So you see it's waiting for me to enter a row value. The scanf is waiting for me to enter a row value. Let's say enter row value is 5, column value is 6, a 5 by 6 matrix. So it says here, see, it prints out the row value which I've read and the column value which I've read, and then it generates a 5 by 6 matrix. So the benefit of this is that now you can, without having to recompile the program, every time I run the program, I can choose another I can generate another matrix, say 7 by 6. So I'll get another matrix value. So this is how it works over here. Okay. Now, there is a risk in using this method. The risk is, let's say, if you were to declare the variable, the array here. Remember, the compiler compiles on a top-down basis. Okay. The compiler compiles on a top-down basis. So when the compiler sees line 20, the compiler will create the assembly code for the array based on the current value of row and column, which is in this case will be garbage value because not initialized. So if I were to do this, if I were to compile a code, I'm going to get a warning. Okay, I'm going to get a warning. That's fine. I keep the warning. And then if I were to run the program now, I'm going to get a segmentation fault. The program crashed because the row and column value are not defined. Okay, the row and column value is not defined. So that's why this approach is not recommended. Okay, if you're not careful, it can be dangerous. All right, so let me undo back again. All right, so the proper way of creating a matrix at runtime based on different row and value sizes as specified by the user is to use a heap memory. Okay, is to use a heap memory. So this is where I'm going to introduce to you all two pointers. This is where we go into pointers. So this is where, this is where my conversation goes into pointers. Okay. Okay. So now, what is a pointer? So now I'm generating a 2-dimensional array, but I'm representing the 2-dimensional array as a 1-dimensional array. Because if I want to create a 2-dimensional array using pointers, we will need to use pointers to pointers. That is a bit more advanced, so I will not go into that in today's topic. In today's topic, I just want to stick to a single pointer variable. All right. Okay. So how do you declare a pointer? So now when you look at this code over here, it's still fairly straightforward. Now a pointer, this is in line 21, we have the pointer variable. A pointer is defined with the star symbol, in this case the multiplication, what's it, the multiplication symbol, but there's a star symbol, which resides between the variable name and the variable type. Okay, between the variable name and the variable type. So it doesn't matter if I put a space bar here, I don't put space bar, if I put a space bar here, it's still the same. Okay, by coding standard, I like to put the I like to just put a space before this, just to specify this is a pointer variable, or you can do like this, so it's fine. It's up to you. All right, it's up to you. All right. So now I put a P here just for coding convention. It doesn't matter. It can be any name. Just be careful in C programming. You cannot start a variable name with a number. It has to start with a character. Okay, an alphabet. Sorry. All right. So then after that, I can put numbers at the back and then in between and things like that. Okay, and you cannot put hyphen. You can use underscore to specify if you want to distinguish certain parts of the variable name itself. All right, you cannot put spaces in variable name. Right? It should be a single word. So I just put a P here just for good coding convention. So this is a pointer variable. This is a pointer variable. A pointer variable. Now, what is a pointer? Very simple. Do not get perturbed by looking at a pointer. Actually, a pointer is very easy. Once you understand pointers, you find it very useful, and you will never feel intimidated by C anymore. Okay. All right. So a pointer is a variable, as I mentioned, which stores an address. That's it. As easy as that. A pointer is a variable which stores an address. Just keep that in mind. Every time you think of pointers, just remember, by definition, a pointer is a variable which stores an address. Now, once you've understood that, okay, now let's look how we can use the pointers then. So this one all is still the same. I'm just prompting the user for the row and column values. This is something very new in line number 33 over here. Okay, I'm using a built-in function in one of the header, I think it's in memory or stdio header files. Okay, called malloc. Malloc stands for memory allocation. So this is what we call as heap memory allocation. Malloc. M stands for memory. ALLOC stands for allocation. So this is a predefined function in C. Inside this function, if you just Google up cmalloc, okay, if you just Google up cmalloc, all right, so allocates the requested memory and returns a pointer to it. All right, yeah, so I believe it's declared inside the stdlib. So you need the stdlib header file. All right, so you can see the malloc is a predefined function. It takes in only one argument. Size underscore t is an integer. All right. How many bytes? When you call malloc, you just tell how many bytes do I want to allocate in memory. It can be 100 bytes, it can be 10,000 bytes, it can be 5,000 bytes, it can be 1 million bytes, and so forth. All right. Okay, you specify how many bytes you want to allocate in memory. And then, should the function be able to allocate the memory for you, as I mentioned just now here, the function will generate the assembly code that in runtime, it will look through the memory to find a contiguous range of bytes in memory which are free, and should be able to find those bytes, it will reserve the entire byte in memory, and it will return the starting address. It will return the starting address. It will return the starting address of that particular. It will return the starting address, meaning that it will return the address of the first byte. Each byte has each cell is a byte. Each byte is an address. It will return the address of the first byte. It will return the address of the first byte as the return argument here. Okay, because it returns an address, let's go back to the code again. A pointer is a variable which stores an address. So we use a pointer that will store the address. We will use a pointer which will store the address of this particular variable. Okay, so that's how it actually works in this context. Now I'm not going into the fundamentals of pointers. I'm trying to explain pointers by giving an example in the context of heap memory allocation. Try to do some self-learning on pointers in tutorials points. The website, I think there's a very good example of pointers. Okay, but nevertheless, if you are having some doubts, you can always consult the lab tutors, or you can consult the lecturers to get further information about this particular subtopic in the C programming language. All right. Okay. So in this case, I'm calling malloc, and I'm specifying row times column times size of integer. Remember, malloc here takes in bytes. So if I just take row times column, I'm only specifying how many cells. Each cell is an integer, so I have to specify this. I call another built-in function of C, size of integer, which will return me 4 bytes. If I want, I can also put 4 bytes here. I can just put 4 bytes here, doesn't matter. But if you would like to add a bit more of standardization in how you write the code, you can just put size of integer over here. So at least it's more uniform in that context here. Should the integer value change depending on compiler you're using. All right. So it will reserve memory based on this value. It will tell you the address. You cast the address to an integer pointer because, as you can see over here, malloc returns you a void pointer. So it's a generic pointer. It's a generic pointer. So you need to cast it to an integer pointer, and then the address is stored inside P array number. It is stored inside P array number. Once you have done that, how you use the array is the same like how you use the array in the first example. Remember the vector? The same. You use a square bracket to access each element of the array. But now, in our case, this is where things become slightly algorithm based. Okay? How do you map? How do you map a 2D position of a matrix to a 1D array? A 1D array. How do you map this? This is a very common common algorithm that you need to understand. It's so common that sometimes in some job interviews they actually ask you this question, and it's something that all of y'all should know. All right. So how do you map a 2D position of a matrix to a 1D array? And actually it's very easy. So we do the same I and J iteration, but inside the array, inside the square bracket of the array here, okay, we take I multiply column plus J. I multiplied column plus J. So what's the meaning of this? What is the meaning of this over here? All right, so let me just delete all of this for a while. Okay. Now let's say I have a 2D array over here. Okay, a simple 2D array. Let's say it's oops. Okay, let's say it's a 3 by. Okay. Okay, so let's say it's a 3 by 3 matrix. Okay, fine. So this is 0, 1, 2. This is 0, 1, 2 over here. Okay, so this means this is location 0, 0. This is location 0, 1. And this is location 0, 2. I think my whiteboard is automatically doing all this. Then this is location 1, 1, 0, 1, 1, 1, 2, 2, 0, oops, 2, 1, and 2, 2. These are location of the matrix. Now, how do I actually map this into a 1D array of 9 cells? How do I do that? Of 1D array of 1 cell. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be 0, 1, oops, sorry. 0, 1, 2, 3, 4, 5, 6, 7, 8. All right. So as I mentioned just now, the formula is what? The ith row of the column, the ith row and the ith row and the jth column. So I times the column width. So this is your column and this is your row. So I times your column plus J. It's a very simple formula. So now, for example, let's say what is the value, what is the 1D value, what is the 1D position What is the 1D position of this cell? 1, 2. 1, 2. Okay, what is the 1D position of this cell? So let's substitute it. So what is the I value here? The I value here is 1 times, what is the column width over here? The column width is 3. What is the J value here? 2. So 1 times 3 is 3. 3 plus 2 is 5. So 0, 1, 2, 3, 4, 5. So the cell number 5 of the 1D array contains the equivalent, contains the value of of row value 1, column value 2 in the array. So that's how you map a 2D array to a 1D array. Okay, how do I map back a 1D array to a 2D array? That's something I'll let you all to do some self-study about it. It's very easy actually. Okay, so in doing so, you're actually making your memory management more efficient than having to do a pointer to pointer to create a 2D heap array. So that's another topic for another day. But for now, this is how it actually works. All right. So going back to the code. Okay, going back to the code, it's quite a lengthy video over here, but nevertheless, I hope it's actually resourceful. Okay, so this is how we actually do it over here. So we're actually mapping a 2D position of a matrix into a 1D array, and then we are storing the random value over here. And then the same thing, when I want to print out the value of the array, I call the array. So remember, it's a pointer, but I'm using the pointer just like how I use an array, because in actuality, guys and girls, okay, in actuality, your array, this is a stack array. Your stack array here is actually a pointer. It's still interpreted as a pointer. It's just that it doesn't appear as a pointer to you in this context, because underneath it, the compiler does creates the assembly that would allocate the memory and store it to a pointer and then map it to this particular array variable. Okay, as a stack array. But if you were to do heap array, this is how actually you work on it, by using a pointer variable to store the address of the memory allocated, of the array allocated in memory, and then this is how you access it. So because of that, when you access every index, it will jump by the integer value. It will jump 4 bytes. It will jump 4 bytes. That's why you have to cast it to an integer pointer over here. All right. So the same thing when you print out, you just print out. So you're printing out a 2D array, a 2D matrix from a 1D array. You're printing out a 2D matrix from a 1D array over here. All right. So let me save the code. Okay. We compile the code now. V3. Before I compile a code, I need to explain. This is very important. Huh? You have to free the memory at the end of the program. Now, in a stack array, as you've seen over here, the compiler will add in additional assembly instructions at the end of the program to deallocate the memory or free the memory. But in a heap context, it is your responsibility. It is your responsibility to free the array when you call malloc. So when you call malloc, you have to free the array at the end of the program. Otherwise, you risk creating a memory leak problem. So which means that region of the array remains in use, although it's not being used anymore already. And if your program runs, doesn't terminate, and if you have a lot of memory leaks, you can actually exhaust out the memory of your system, which in the past, in older operating systems, could actually crash the operating systems. But these days, operating system kernels have measures in place to actually kill the program before the program kills the operating system. So yeah, so that's something I thought you might want to know. All right. So just be careful. Just remember to free the memory for heap memory. So let me compile the code. There's no errors over here. I run the program. It asks for the row value, column value, and then it generates the value. So you see, in terms of the usage to the user cannot. I mean, the user doesn't understand. I mean, cannot see that at the back you're using a pointer. But the benefits of using a heap memory are quite a lot in terms of using, other than using the earlier example of using a stack type array with variable length array size. One is heap memory allows you to reallocate the memory. There's a function called reallocate, which allows you to reallocate the size of the memory, to adjust the size of the memory based on new, let's say you have an algorithm, the algorithm runs, and during runtime, it determines that you need more memory. You can actually call the reallocate memory. This is something you cannot do with stack array. So the heap array has a lot of, has several advantages. One advantage, as I mentioned earlier on just now, of using the reallocate function. Okay, so I mean, and in this context, it is very important for you all to understand how to use pointers, because we will be using pointers quite a bit in MPI, in message passing interface. But once you get the idea of pointers, it is fairly simple already. Okay, so this is the idea of this particular example here. Okay, now moving on to the next example, V4. So now now you see, I'm generating a matrix over here. I would like, what's the point of generating a matrix if I can't save the matrix, if I can't store the matrix? So now I want to store the matrix into a file, which I then can later use for some processing and things like that. That is where the next code comes into play, matrix version 4. Okay, so this one creates a matrix using heap memory, but I have one extra step, which is where I write the matrix to a file. I write the matrix to a file. Okay, so inside here, all right, so now I'm going to introduce you to functions, how you can create your own function in C. So that's now, as I mentioned, every C program, every console or terminal-based C program requires a main function as the entry-level function. But you can also create your own function as part of your modularity. I mean, creating functions are something you're very familiar with from Python and Java also. So there's no difference here. It's just in Java, you create classes, and then in the classes you have member functions. And then in Python, you can create functions to have some form of modularity in your program. And the same thing in C, you can create functions also. All right. Okay. So what I'm doing, the first part here is all the same. Okay, now this time I have a file name. I prompt the user for the row and column. I ask the user for the name of the file. I ask the user for the name of the file. Okay, for the name of the file to store the matrix in. Okay, to store the matrix into. All right. So I can use either scanf%s, or I can use fgates. Fgates, the benefit of using fgates is that fgates allows you to actually store a name which got a space bar in between. Let's say matrix space bar A, something like that. If you use scanf%s, scanf sees the space bar as the space character as a delimiter. So that's why we can use fgates, but I think I've forgotten to include an additional code inside here. Just 1 second, guys. I should, because the problem with fgates is that fgates tends to capture the trailing /n also. So I need to put in an extra code inside here. I did it in the earlier one. I can put 256 over here. All right, and I should do this. Okay, so what this function does is the string chr function looks through the name, all the characters, finds any character with /n, and then changes that value with a 0 over here. So I mean, these are some new terms. I'll put the code here, so don't worry. I mean, if you don't understand the code, we can discuss it. You can consult your lab tutors to ask them to explain to you about this code, or your lecturers also. All right. Now, the reason I'm calling getChar twice is because when you call scanf and you hit the enter key after entering a number, the /n still gets stored into the std in buffer. So by calling getChar, in a way I'm flushing out the buffer. Okay, before calling fgates. So fgates gets the file name, gets the name from the screen, gets the name from the terminal, and writes it into an array. I'm using a char array here, a stack array over here. Okay, and then I call malloc. I generate a random array, and now you see I'm calling the function write to file. So this is my function definition. This is my function definition. Okay, my function definition. I call a function write to file. The function takes in a few arguments. I created this custom function, the file name, the matrix pointer, the row, and the column. Okay, inside this function, I declare a local variable. So this all the variables here, whatever variables are declared inside here, lives and dies within this function. Okay, that's why the scope is very important over here. All right. So inside here now, I'm using a file pointer. So a file pointer is a built-in C file object pointer. It's actually a pointer. It's like a it's in a way it's an object to a pointer by itself. But I think we'll use it's defined inside I think the std_lib header file, if I'm not mistaken. So then we will call a variable of this file pointer, okay, this file pointer, and then we call the fopen function. So the fopen function is a built-in function in C. Okay, we call fopen, specify the file name, and we open the file for what? Writing. So now we are doing text-based processing. If you're doing binary processing, you have to put the B here. But we're doing text-based processing, you just put W to write the file. And then instead of calling printf, I call fprintf. So fprintf is same like printf, but I'm writing to a file. So I'm writing the row and column value into the file at the beginning, and then I write the entire content of the matrix into the file. So rather than printing the matrix to screen, I'm writing the matrix into the file itself, and then I close the file. Okay, I close the file. So this is what the code is doing over here. All right, and when I call a function, write to file, and I call the function, okay, when I call the function, write to file, I pass in the file name. So when I pass in the file name, I'm not passing in the entire array into here, because the array is a pointer by itself. This file name is actually a pointer by itself. It's just that it appears to be an array, but internally it's a pointer. So when I pass in the file name into here, into this function, okay, the pointer here just points to the same file name in memory. And same thing with this pointer matrix. When I pass in the p array num, I'm passing in the address, the starting address of the array in memory into here. So this matrix also has the same address in memory, but these two variables I'm passing in by value. I'm passing in these two variables by value into the function. All right. So what happens? It opens up the file name and writes the content of the matrix into the file, and then closes the file. That is what this particular function is doing. Please go through the function. Please read the function and use this week's lab to actually consult your lab tutors if you're not familiar with some parts of the code. All right. Okay, let me save the code. Here, let me run this v4. I think there's an error over here. Oh, yeah. I forgot to declare the variable integer position. So you can see here, if you want to debug the code, it shows line 58, column 9. So if you go to the code, it shows here line 58, column 9. Actually, it's after, yeah, I put a new line just now already. So I just put integer position, my bad. Wait, comparison between a pointer and integer. Wait just 1 second, guys. We seem to be having a small problem here. When I declared the position over here, oh, sorry, it's not an integer position. My bad. It's actually a char pointer position. All right, it's a char pointer position actually. Yes, you're getting the position as a char pointer because it returns you the position of the char character. Okay. All right, so let's run the program again. Yes, now it's fine. Okay, so now I enter the row value 5, 6, and then now it says specify the name of the file. So let's say I call it as matrix. Let's say I call it as matrix.txt example. Okay. So then now you can see in your folder, you will have the matrix.txt created. Oh, I think, I feel that's a small mistake over here. I think maybe I shouldn't have specified the position equals to strch here. Maybe I should just try to Hide this for a while. I'll probably look into this again and get back to you all, ask the tutors to get back to you all on this. All right. Compile the code again. Doesn't matter, you get a warning that this variable is not being used, it's fine. Out 5, 6. Let's say specify matrix.txt. Okay, so now let's look at our folder. Oh, the weird thing is for some reason the M seem to have disappeared. I think probably it's got to do with we seem to have a very small bug inside here. So it's nothing to do with us deleting this. I think I kind of overreacted here. 256 file name, get the file name 256. Yeah, but normally we'll look at 255. Should I put it as 255 then? Yeah, all right. Apologies for that. Seem to have some bugs. So this is quite common. We do find some problems and we try to solve it. We have to solve these problems. Let me delete the files first. Okay, out. Let's say I put it as 5 and 6 and then let's call it matrix.txt. Yeah, the good news is the matrix file contains everything. The not so good news is for some reason the first character of the matrix files got missing. I got a feeling that this got to do with the F gates misbehaving again. If I were to delete this and put this, just tested it just now, it's working fine. Maybe something I forgot. Aha, yes, now it's working fine. Oh my goodness. so apologies for that slight shenanigans over there. Okay, right. So now the thing, you see, the reason why I'm using getchar is because I'm trying to clear off the /n. Every time you do a scanf, the /n will be saved. The number will be saved into the variable here, but the /n will still remain the buffer. So I call getchar, I should call it actually getchar once and not twice. That's why the earlier M was captured inadvertently, I guess. So yeah, I should go back to 256. It should be 256 actually, the size of the buffer. So that's why I use getchar. So just be careful. F gates tends to have this problem. If you're using a name which has a space bar in between, then you should use F gates. But if you're certain that the name is going to be a single word, then you can probably use scanf%s. It's actually that's the difference. All right. So apart from that, so let me just run the code again. I think now it's clean already. Compile again. Okay, out 5, 6. The matrix file, matrix.txt, and good. Now we go to our file. Now we see we have our matrix file written inside here. Now, what is the benefit of this? The benefit of this is that now I can generate large matrices. So let's say I generate a row value of 500, a column value of 400, okay, and matrix.txt. So you can generate large matrices using this file. You can generate large matrices using this file, and this can be very useful later on when we go into matrix multiplication, our next task. All right. So this is how it works. This is how we actually create a function. Now, what I've done is I put the function before the main function over here, the write to file function. You can actually move this function to the bottom. You can actually move this function to the bottom. But what you need to do is you need to specify the function prototype. The function prototype at the beginning. So the function prototype is just merely the function skeleton. The function prototype. So type 2. Oops. The function prototype. All right. So the function prototype is specified here. So then you can have the function at the bottom here, because the compiler compiles top down. So the compiler compiles, searches for the function, sees the function being called. It compares the usage of the prototype is correct, and then it compiles the other function over here. At the linking stage, it will then link the function to the actual function call over here, definition to the actual function call over here. All right, so it will still work the same also. Okay, so 10, 6, and then matrix dot txt. All right, then if I go to the file, you overwrite the file with the new content over here. Okay, so you can choose the append also, rather than calling A, you can call A, so A will continue appending to the file. Right, you would always flush out the current text file and then write in a new content and text file inside that. All right, and finally, the last example I wanted to show to you all is, once you write this version 5, reads the content of the matrix. So now I have a new function. I'm not generating a matrix anymore. I'm going to read from the file and print out the content on screen. So same thing, I'm going to skip this part. I ask the user for the name of the text file. I get the name of the text file. I call a function read from file. Now look carefully. This is where things get a bit interesting. Okay, this function read from file takes in a pointer to the file name. Now look here, these two variables are integer-based variables. These are variables where you pass in the variables by reference or by address in C programming. So this is something different from Java, where you pass in a variable by address in C. So which means that this function can return multiple arguments in the function and also in the return type. So in this function over here, I have the file pointer. I open the file, and then I read the row and column value from the file. And then based on the row and column value, so you see here, I've created the file just now over here. This is the matrix file I created. So this is the row and column value. It reads the row and column value, fscanf, and then the pointer moves to the, after reading here, the pointer moves to the content of the matrix over here. And then it creates a dynamic matrix. This is where the heap memory comes in very useful. Okay. It creates the heap memory, stores the address into here, and then it reads each element. You see, I'm using fscanf now to read each element of the matrix cell into the address of the array at location I times column plus j. So this is reading a 2D matrix into a 1D heap array. Use heap. All right. Okay, go to the code. Guys. I know I'm not going in depth. All right. I would like you all to try looking at the code first. All right. And then you see, I'm dereferencing the pointer. When I dereference the pointer, this is a pointer. I'm looking at the variable outside of the function, where the function was called. Okay, I'll come to later on a bit. And then I'm storing the value into there. All right, dereferencing the pointer. And then I return the matrix. I return the address as a return argument here. So you see, when I call the function, when I call the read function, read from file function, okay, you see, I declared a pointer. This pointer is currently null. I can put it to null over here. Null is built-in, okay, equal to 0. All right. So I pass in this pointer as a return value of the function, and then I pass in the file name which I've read from the user fgates. Here's the part. You see, remember, a pointer stores an address. These are pointer variables. A pointer stores the address. So I have row and column declared in the main function. This row and column is different from the row and column inside here. These row and columns belong to this function. These row and columns The scope of these row and column variables belong to this function. The scope of these row and column variables belong to this function. Now, you be wondering, why not I declare them as global variables? Yes, I could, but we try to minimize the usage of global variables however possible in C. I mean, we will, at sometimes we might have to use them, but we try to minimize them if possible, okay? All right, so in that context, okay, what happens is, I'm now passing in the address. You see, I'm passing in the address of the row, the address of the column into this function. So what happens is this pointer and this pointer are now pointing to the, stores the address of the row and column variables in the main function. So that's why when I dereference the pointer, I'm telling the compiler, go to the address, look at these variables for the address, go to the address of these variables, which is the row in the main function, and take the value of the row of this function and store it inside here. And you do the same thing for column also. So after when you return from this function, the row and column now contains the values which were actually inside this function. Okay, so when you print out, you will get the row and column values, and then the P array now stores the address of the malloc created in the function here. You print out the values here, like how you print out the 1D array as a 2D representation, and then you call free, because you have to free the array which is created in the function over here. Same thing, guys and girls. Same thing. You can have the function definition over here. You can have the function definition over here, and then you can have your function prototype over here, whereby we just specify the function prototype. This is where you can use a separate header file and separate C file. Okay, but maybe that's another day. All right. Okay, so now this matrix version 5 doesn't generate a matrix. It reads from a text file and prints out the content of the matrix. So this is very important later on when we start doing our matrix multiplication. Okay, which we will start looking into in week 3 of our lecture. All right, so compile. Oops, sorry, I'm compiling a wrong one. I should be compiling version 5. Okay, no errors. So now enter the name of the file. So if I specify a wrong file, it will say cannot open the file because this file doesn't exist. The actual file is what? The actual file is matrix.txt, and then it reads the file, and then it prints out the value of the matrix here. All right. So this is a general introduction to C I wanted to explain to you all. All right, I know it's quite a lot to digest for you all. It's quite a lot to digest for you all at this point, but don't worry about that. Okay, this gives you an idea on why pointers are important, and why we will use pointers quite a bit we will use pointers throughout the semester for C language. Don't be perturbed by pointers. Trust me, it is actually once you understand the concept of pointers, which is store address, the rest of it becomes fairly easy to follow in C programming. Okay, so generally this is about it. Okay, so please go through them, and I think there are some extra videos about pointers in C. I have some good videos over here: introduction of pointers in C and C++, and pointers in C. I think I'll pass these videos as additional description in the video. All right, so you can refer to them over there. And yeah, that's about it for today's video tutorial. The code will be made available to you all. Then you can refer to the code for your own referencing. Okay, so that's about it. If any questions, you can consult the tutors, you consult the lecturers, you consult myself also. All right, so thank you very much for your time to review this video, and I will catch you again in the next video. right? Thank you very much and have a good day. Cheers.